Learned that from the last two presentations. It's a good one. So always learning. So just a bit about myself. My name's Adelle Holmes. I've been at Clarendon for about 25 years, give or take, with some leave. We've had many visitors to Clarendon over my time, and we also like to visit other schools. We're a school that loves to learn, and we certainly love to have people here sharing their knowledge and sharing their learning with us. When people come to visit us, one of the key questions that I get asked as head of maths is that one that's there on the board, is how do we accommodate students with varying levels of maths understanding when we're teaching with a common curriculum. So this burning question is the basis of my presentation today, and as I move through and explain, I'll keep adding to, hopefully, the answers and have it answered by the end. So I'll aim to explain what we first of all mean by a common curriculum, the support structures, and the research behind why we think it is a good model for instruction. Firstly, you should know that at Clarendon, we subscribe to an explicit teaching model of learning, if you didn't already know that. Throughout my presentation today, I will not ask you to read something at the same time that I present something, so that you don't need to actually make a decision between which you engage with, whether you engage with me or whether you engage with the learning on the screen. So please read this. This is from a quote from Greg Ashman, which was from about 2015, and we're obviously 10 years down the track here, and we've been able to, and Greg, by his own admission, has been able to probably come up with a little bit of a better definition. So we've actually been working on this for a long time, and since Greg probably came to the school in 2010, 2011, we've always been interested in research, and we've always been interested in learning at a school, as a school. And it would be really remiss of me not to acknowledge the work of Greg Ashman and the school in my learning to be able to present today. So to begin to answer the burning question, if we want students to know something, we teach it to them. Okay. The common curriculum maths lessons at Clarendon have been developed based on Rosenshine's principles of instruction. I'll give you a moment to review these. They're quite a lot. So these are essentially the rule book and the guide for lesson development at Clarendon. We usually start our lessons with some sort of retrieval or a review of previous learning, and then we'll start to work through our way through these until we get to the end. And all of our lessons from about prep to year 12 are based on this. So we usually get to the new learning about here. So this is going to be pretty much what my presentation is on today. So 2 to 16. So I'm going to sort of assume that the previous learning or the retrieval practices occurred, and then I'm going to talk about pretty much the nuts and bolts of a lesson. We don't assume anything when students come into our classroom. We do group for instruction, but as I said, I wouldn't come in and make some assumptions on what students would know. I would base that on what they're showing me on their mini whiteboards. Okay, so this is going to be the main part that I'm going to talk about today, and I'm going to talk about how we formatively assess this. You should know that at Clarendon, our tool of the trade for assessing whether students know something or not is the mini whiteboards. So we use this over cold calling, because then what I'm doing is I'm getting the information from all the students rather than just some. So what do I mean by common curriculum? Well, at Clarendon, we are all involved, all staff are involved in preparing the curriculum. Here's a little snip of a Year 6 unit that is currently being taught as of this week. And these are just 5 of the, I think there's 8 or 9 lessons. And so we actually have a PowerPoint for each of the lessons. So here would be lesson 1, in this fractions decimals unit. Then we have lesson 2, lesson 3, lesson 4, lesson 5. And so within that PowerPoint, we would have our lesson resources. We would have what I'm going to call essential examples. So they are the core content that we have decided we are going to teach in that lesson. And we usually have about 4 to 8 things that we will teach in that lesson, depending on the level of difficulty and whether they've encountered them before, but we'll call them new learning. And we make them a different colour so that they're really easily identifiable for the teacher. And each teacher must teach those as a minimum in the lesson. So regardless of the group that they have, they will all teach those essential examples. Then we have our stepping out. So this is essentially, this is exactly what it looked like this week. So you can see the dates. So we have 5 groups. So we have teacher A, teacher B, teacher C, etc. And so on Tuesday the 11th to the 3rd, each of these teachers actually taught lesson 1, on Wednesday, lesson 2. So regardless of whether you've got a further group, an expected group, or an earlier group, all those teachers taught lesson 1 on that day. It is often one person's responsibility to put together a PowerPoint, which is a unit of work for others in the same year level. This doesn't involve rewriting the PowerPoint, so we never ever throw out the baby with the bathwater. We've gone through this process a lot of adding to our PowerPoints, and so when we decide that we come up with a new strategy or an additional strategy, we never ever throw out what we have, we always just add to it. And so our PowerPoints have been refined over many, many years. Some units have been refined over a longer period of time than others. Some year levels have been refined over a longer period of time than others. So we're all at a different place a little bit. So when we make a decision about updating the PowerPoint, we base that on data. All of our decisions that we make at Clarendon on our instructional practice or our curriculum is always based on data. As teachers, we are bound by the agreed strategies that are within these PowerPoints. That doesn't mean that we're robots and we have to teach it a certain way. What it does mean though is that if we want to actually if we want to change it, then that would be a process that we would work on collaboratively, and we would base that on data rather than that just someone wanted to make a different decision on that day to actually teach it. Because often we're teaching it a certain way based on information that we've collected formatively. Okay. So phase 2, I talked a little bit about how we collect information to be able to update our curriculum planning. And so phase 2 is where we actually talk about our curriculum development. And we always base our improvements on data. So in phase 1 is our unit development. Phase 2 is where we make the changes to our curriculum. So in those meetings that we have with all of the stakeholders, so all of the teachers, we will actually talk about the assessment. So we need to make sure that the assessment is valid and that it's reliable, because we're making a lot of judgments based on the data that we're being provided with. So here is an example of what we might look at in a phase 2. So for example, if this were my 5 groups at year 6, it might be that you can probably make some judgments here that group B might be further along the developmental pathway, and that might be the attainment or percentage on those particular questions on a previous assessment. Obviously we haven't assessed that one yet because we're still teaching it. But you can't make any, the main thing about this is that you can't make any assessments that just because they're further along the developmental pathway that they're actually going to be better or perform better than some other groups. Now, what we often identify is that even though we're all teaching exactly the same essential example, we all taught it exactly the same way because the PowerPoints actually mandated that, like we all agreed that we were going to teach it this way, there'll be something that will have happened in that class where the teacher will have actually taught it slightly differently. And so what we do is we would get the teacher whose class performed better. Now, just to be clear, it's not about teacher performance. This is about student performance. and more importantly, curriculum performance. So this is what is not in our curriculum that's not supporting our teachers to be able to teach the same, or to teach the same. So what I do is I would probably get, for example, in question F, I would get perhaps not teacher F, the group E teacher to get up, because this is actually, they're actually further along. What I might do is I might get group A teacher, who these students are typically been earlier along the developmental pathway for all questions. There's something that teacher has particularly done in that class. So I would ask them to come up and teach that exact same concept, whatever it was. And then, because what usually happens in those meetings is the people say, so what did you do differently? And they say, oh, I taught it the same as the slides. But when they actually get up and they teach it, yeah, they've used the same agreed strategy because that's what we do, but we might have said something differently. We might have told a story. We might have said, well, when you add to your, I don't know, some story. And so now that story goes now to curriculum development. And so we make a record of the, whatever it was, whatever made the difference for that particular curriculum goes in, and that change is now updated. And then everyone teaches that next year because we know that made a difference for the students. So this is what it looks like a little bit. We teach, obviously. We assess, and we use summative assessments to base our phase 2 data on mainly, and we always use data. We'll have our phase 2 meetings, so we will meet weekly, fortnightly, and we'll only usually talk about data in that meeting. And then we'll make changes to the unit. Now, when we make changes to the unit, we're very specific and explicit about how that will be done. So, for example, notes will be added. Make sure we add an essential example that does this. And we will, if there was a major misconception, we actually add a yellow box. So we will say, add a yellow box that says x squared does not equal 2x or something like that, because that's obviously a major misconception that pops up, something like that. So we'll be really explicit about what we're actually adding. And sometimes we might even say, see Adelle Holmes, if it's something that I've added, so that the person who didn't quite know what that was about can actually come and see me and then ask me what I did. Okay, so grouping for instruction. As I stated earlier, we do group for instruction at Clarendon. We call it a developmental pathway. So we will talk about students that are earlier on the developmental pathway. We'll talk about students that are in the middle at the expected level. And then we'll talk about the students that are further along the developmental pathway. Now, I'm going to refer to this because of some of the research that I'm going to reference as a novice learner and an expert learner. Okay, so we're working along there towards achieving mastery through the learning. So you can think of this as being students that are earlier on the pathway. You might think they're about there. Then we group them and we have a look at the data, and so we put them into a group and they're about there, and then we have the students that are further along. The reality is that when we look at the data, it looks a bit like that. Okay? So that probably is about right. That's about, and then we get mixture in the middle. Okay? So although we group for instruction, we know that it would be very dangerous for us to make assumptions about what students do and do not know based on how they went on the previous topic, given that we don't actually know how they are going to go on this topic. And if I took, and this is a bit hard to conceptualise, so I took that data, I turned it upside down and took out the numbers, just to show you that this is actual data, and it actually shows you how poorly we actually get that grouping for instruction, and how we kind of a little bit right, but how it'd be very bad to actually make assumptions based on what students know, based on they're an early group, they won't know this, they're a further group, they'll know this. Okay, particularly here and here. Okay. So adding to the burning question. We're very careful about how we design our curriculum resources. We are really consistent about our delivery. We're very careful about what goes in it. And we're very careful to make sure that it's informed. And it's always informed on data. Sometimes, very rarely, there's a bit of a I reckon. But most of the time, it's based on what the data is actually telling us students do and do not know. Okay, I'm going to digress for a moment to talk about the research behind the next bit I'm going to talk about. And I am going to refer to my notes quite heavily because I've got to make sure I get this right. Okay, so in a 2006 study, a study was conducted by Rodiger and Karpicki. The study compared how students performed after studying combinations. So I'll start again. Students performed after different combinations of studying and or being tested on material. They found that studying, followed by a test, in which students wrote down everything they could remember, led to a better final recall in a final assessment than given an additional study opportunity. So getting them to recall something onto paper rather than go and do some study actually improved their recall or their ability to remember the information in the long term. That's really important to what I'm about to talk about. So it appears that the process of retrieving information from the memory, it actually helps it to be consolidated in the long term. And so in here we call this the testing effect. So just to be clear, when I talk about testing, I'm not talking about giving the kids a test in the classroom and saying, can you tell me what x plus 6 equals 4? What is x? What I'm actually doing is I'm saying to them, getting them to show me on the mini whiteboards, what does that actually represent? So it's not for a grade, it's not for a score, I'm actually testing the information. I'm testing what do they actually know, what interventions do I need to put in place to inform the next decisions for them. So, to continue to add, we test them a lot and we ask them a high volume of questions and we encourage them to retrieve information from their long-term memory a lot. Now, I actually, in preparation for today this week, tried to actually record how many questions I asked my class, and I was trying to teach and trying to record how many questions I asked them. I lost track at about 50, and that was within a 70-minute lesson, and that was probably about halfway through. So just so you know, a typical class at Clarendon, students would not be working independently on tasks. They would be with us, working with us the whole time, regardless of the level of attainment. Because we don't make assumptions about what they know or what they don't know. We actually check all the time as to what that is. William and Black, in their 1990 article entitled Assessment in Classroom Learning, found the typical effect sizes of formative assessment practices in the classroom range between 0.4 and 0.7. They emphasised that effective informative assessment involves ongoing assessment in the forms of both teaching and learning, providing timely and specific feedback. So, let me read that. And so that is the sort of thing that I'm talking about. When I'm testing them, I'm getting evidence of the learning from the mini whiteboard, I'm providing feedback. I'm not giving them the answers, that's really important. I'm looking at their whiteboards and then I'm judging next steps based on that. It would be really lovely. In Sarah's presentation, if you were in here a minute ago, she said it would be lovely, we have a script. I thought, well, that would be nice to have some sort of prompts. But in my mind, I'm making those decisions based on what the students are showing me. And we're doing this multiple times a lesson. The importance of effective feedback was also supported by John Hattie and Helen Temple's 2000 article, The Power of Feedback, which found that based on the collective average effect size of feedback, student achievement, as shown, was found to be about 0.79. Now, I'm not a researcher. My understanding of effect size is that effectively it's a standard deviation or a standardised score. It's a measure of how much something deviates from zero. So these are all pluses or all positive values, which means that they all make a difference to student learning. Now, so feedback equals good. Feedback in the moment through mini whiteboards, getting kids to recall, testing them, get information backwards and forwards, that has to be better. So feedback at Clarendon in the classroom in the moment is not taking out books It's not writing copious amount of feedback. It's giving them moment-to-moment information all the time. And it's not individualised. So if a student shows the wrong answer, I don't say, hey, you've got the wrong answer there. It's more about giving information to the whole class and then them taking on the feedback to actually change what they might do in the next step. And I'll give you a demonstration of that in a minute. Okay, so we provide feedback in the moment to inform the next steps, and we use formative assessment to do that. So, the structure of our lessons at Clarendon follow pretty much this sort of format from around prep to about year 12. What we'll do is we'll have what we call an essential example. Now, the background colours are important. We have peach, just because it's peach, for an essential example. And the reason that we have it a different colour to the other white slides is because it's easily detectable in a PowerPoint slide by the classroom teacher. It's also really useful when we're creating student resources, and I'll talk a little bit about that in a minute. Then we will create a solution slide. So every one of our questions will have a solution slide, and on that solution slide will be the agreed strategy for teaching it. So the classroom teacher will be clear about that. Now, if it's not clear, that's where the phase 2 data tells us it wasn't clear what the agreed strategy was. I thought it was this. I thought, okay, so we need to go back and we need to make that adjustment for next time. And then we've got these other slides at the end that we call independent practice. Now, I just said a minute ago that we don't do independent practice much in our classrooms at Clarendon. That's true. So why is it called independent practice? It's a good point. But they're called independent practice because initially we thought, well, if we've got some extra time, perhaps we give it. No. So basically, this is our resource that we call independent practice slides. So we will pick questions from these. Okay? I think we need to rethink about the label. Anyway, and then at the very, very end, we've got what we call extension. Okay, so they all follow this pretty much this format. And in every PowerPoint that I showed you a minute ago, there is about 4 to 8 of these per lesson. So it'll go through the cycle. And there could be multiple of these. So I've got multiple questions that I don't need to think up on the spot. I don't need to make up questions. I can just pull from that depending on what the students are showing me on the mini whiteboards. So, to break it down even further, it looks a little bit like this. So, let's say I've taught something, and I've taught it really well. Maybe, who knows, right? So I'll give the students an example, a very, very similar you do to the one that I did. And I get 80 plus success. Now, the 80% success rate comes from Rosenshine's mastery principles. Now, I'm a perfectionist. So I'm a 90 plus sort of person, maybe 100, but 90 plus, so I'm looking for that. So 80% is the guide, yep. And then if they get that, then I'm off to the next essential example, okay? So, and also because I'm a perfectionist, I might not decide to go to the EE. That's up to me. What I might do is I might go, was that a fluke? I might give them one from the independent practice just to make sure it wasn't a fluke, and then I'll go to the next example, right? So these students that are further along, they've got some mastery, they've got automaticity of this skill, they're going to get to the next EE pretty quickly. If they don't get 80%, 90%, then what I do next is sort of where I want to say the magic happens, right? So this is the testing. This is the formative assessment that I alluded to a minute ago. So this is where you're working really hard. Is there a misconception? You're looking at the mini whiteboards. Is there a misconception? What is it? And what's really important is what I do with that. Do I say to the students, X equals 2 is the answer? Well, that doesn't tell them that what they got was right or what was wrong. If it's really gone bad and I've got a whole lot of different answers, then I'm going to say, let's just stop for a minute, and they put their boards down. I don't tell them that they're right or whether they're wrong because they're going to actually figure that out for themselves a little bit, but I'm going to guide them with that. And so what I'm going to do is I'm going to reteach that. I'm going to go, okay, Obviously, they weren't ready to do that on their own. I'm not going to tell them that, but I'm going to say that in my head, and I'm going to reteach them. What do I need to do to bring it back? Maybe I needed to show them an earlier step or get them to show me what was stopping them from getting to that point. I'm going to go back and I'm going to break it down into even smaller chunks. I might ask questions. I might say, remember when we talked about that? Well, do you remember, what did we say? And I might actually start bringing them into the conversation a little bit. And this is a personal favourite of mine, where once I've given them an intervention, I say to them, okay, now I want you to keep or change what's on your whiteboard and give them the opportunity to correct their own misconception. Because then what you're doing is you're getting them to really think about what their answer is. I don't give the kids the answer. Then, once I feel like that's gone okay, obviously they haven't reached mastery, so they're going to do a backup question. Okay, so I'm going to pick a question from the independent practice slide, and we're going to go back to the start, and we're going to have another go at another one. And then, because they didn't reach mastery at the start, just to make sure that the next one wasn't a fluke, I'd probably go and do another one. Okay? So if the students haven't mastered it at the start, they're going to be in this cycle of going through with this intervention with me a little bit longer than the other students that have already up there and they're on to the next example. And then when all students have completed all the essential examples, and our lessons are structured so that we do get through the essential examples regardless of your grouping for instruction most of the time, then teachers can make a decision to go and do some of the independent practice slides. They might go, well, I wasn't sure whether they quite got that, go and pick some of those, or then the students can move on to extension. And I'll talk to you about extension in a moment because we think about that really carefully. So in my mind, it kind of works a little bit like this. The long-term memory, and we've got the working memory. So that arrow represents the intervention that I'm doing. The students are going from long-term memory to working memory, back again. As I'm questioning them, I'm getting them to work with that concept, backwards and forwards, backwards and forwards. I'm testing them. I'm getting them to actually construct something in their long-term memory for the long term that they'll be able to use. The footsteps represent the pace, okay? Some students will be more automatic in this process than others, and that's okay because I'm going to be able to gauge that with the lesson and I'll be able to use the mini whiteboards to gauge the pace. So that's where the accommodation part comes in. It doesn't necessarily come into the resources I'm going to provide, it's in this part. This is where I'm accommodating. I just want to give you a moment to have a quick look through that. Okay, so this diagram from Adelle, and I'm a bit of a Star Wars fan, so I liked it in particular, was we're moving from a novice to an advanced learner, or an early to expected to further learner. So depending on where they're at in their learning, I'm actually giving them fully guided, regardless of where we're starting, it's fully guided at the start anyway, because I'm not going to make any assumptions. And then I'm kind of keeping them here, and I'm making judgments based on what they're showing me on their mini whiteboards as to where we go from there. So, what does it look like? Here is what a typical class at Clarendon would look like, except for the kids would be in uniform. And they would all have one of these. This is a book listed item. And this would be a no assumption zone. So I'm not going to assume anything about their understanding. So hopefully remember that I actually tried to make a point of the peach slide being the essential example, the blue slide being the solution. Here is an example of what an essential example would look like. So we have this skill that I've plucked out of air where we're asking the students to actually balance an equation, and you'll notice here that they're actually quite similar. So there's a few features I want to point out. First of all, we call it an essential example. We do use an acronym EE, for short, and the kids all know what that is. So the I do, you'll notice exactly the same wording, reducing cognitive load at this point because they're novice learners, so that's what we're doing. Pretty same sort of question. You'll notice that they're going to get a positive answer. So we haven't made the questions different, that they're going to get a negative answer. We've made them as similar as we can. You'll also notice that we have an icon up in the top right-hand corner, which we call a consistent cue, and that is throughout the school. So the students know that they have to do that on the mini whiteboards. They kind of know that anyway. Now, for these ones, we would always print the essential examples for the students in a booklet. And the reason that they're peach is, well, so that we can identify them in a PowerPoint, but it's really easy when we're putting together the booklets because we know we've got to put all the peach slides together. And then we don't always print the worked examples, these ones over here, because they don't actually need them because they're doing them on their boards anyway. And the reason we print them is for a couple of reasons. One, because if they're allowed to use notes in assessments, which they are, if we're modelling it for say BCE subjects, then we might. Or if they're doing it for homework, we want them to have an exemplar model so that they are able to do their homework. Okay, so that's sort of what it looks like. Well, not sort of, that's what it looks like. Okay, so here would be an example of the blue slide. So that's a solution slide. And so that's our agreed strategy. So when I teach it, regardless of how I want to teach it, we are going to put -3 underneath here, -3 underneath here. We are all going to do it the same. Now, there's not a lot of detail in there. So there's a lot of room for movement there. And we might pick it up in phase 2 that we needed to put more detail in there. We might not. We might not be an issue. But we do all put our answers in an answer box at the bottom right-hand corner. Okay, so here's what I need to explain. So what I've tried to do is I've tried to put what I'm looking at here, what the students are looking at here, and normally the students would have the I do here, but I didn't want to put that on here because it would make it too small. So the students are looking at the I do that I've done, and they would see that I would have worked it through, and that would be on the board, and they would have that to look at while they're doing the you do on their mini whiteboards. Okay? So this is what I'm seeing. Okay, so I'm going to imagine that I've got a further group here. Okay, so if I ask the students for the answer and they said x equals 2, how do I know that they actually know that they know what they're doing? Well, I don't. Did they pluck 2 out of there? I actually don't know. So it's really important that I'm asking the students to show me they're working. So my first step to the students would be, show me your first line of working, and I would have modelled the first line of working. So I'm expecting to see x equals 4 minus 2, and that would be modelled on my I do. And they would all do that, and assume they all wrote that in a perfect world. And then I'd say, okay, now show me your next line of working. 3, 2, 1, and they show me that. Okay, so this further group, they've hit the 90, my 90, definitely the 80% mark, and they're probably ready for the next EE. But just to make sure it wasn't a fluke, because I told you I was a perfectionist, I'm going to pick one of these ones from my independent practice slides for the students to do. So I might pick the one on the left-hand side, and let's say they all showed me the working and they all got it right, and then bingo, away we go. These guys have reached mastery of this skill. They're on to the next EE. Okay? Consider a expected level group. So same problem for an expected level. So again, the I do would be over there and it would have been modelled for the students. And let's say they show me this. There's a clear misconception. So I don't know what percentage I've got, but I've got a mixture of kids showing me a bit of both. So obviously this is the one I want to see. That's the one that I'm seeing. What I might do at that point, or what I do at that point, is the really important bit. What I don't do is don't tell them x equals 2, or you should have x equals 4 minus 2. I don't do that. I say to the students, just remember when we were over here, remember how we had to subtract the 3 to make sure that the equation balanced, or whatever I said when I was doing the modelling. And then I say, let's think about that in terms of this one. Now keep or change your answer. And then they do it. And they get that. So they're actually coming up with that on their own in the moment. And then they get that. So they've actually been able to get that level of success. But more importantly, I'm actually checking their understanding and I'm testing it. They are definitely going to be doing another one. Okay, so they do this one. They all got that one. Okay, so that little intervention meant that they were then able to get that one out and they got that. But I'm going to do another one. Okay, I would definitely go and do another one with those. Let's consider an early group. So again, similar sort of scenario. And I get this. Now, we've got a mixture of things going on here. Here is where what I do again is really important. I'm not going to say, if you got that, you got it right, well done. What I'm going to do is I'm going to lead them through it. So I would actually stop. I would say, okay, everyone, boards down. I'm going to show you how to do this again. And I would actually go and model this. Even though it's a you do, I would actually stand up here and I would model it exactly the same as I did the I do. And I would do the first bit. I would say, we're going to put -2, -2. Okay, now keep or change your answer. And then hopefully they write that. Okay, so what I would do is I would backtrack and get them to do that. What I might do is after I've done that is say to them, tell me what I need to do to both sides. So I'm actually breaking it down into even smaller chunks so that they can so that I can see that they know what they're doing. I'm sort of keeping them in this holding pattern a little bit longer. And then they all show me that. Because I've gone a step back and I've put a little step in there. They know that they've got to subtract the 2. Now we're at x equals 4 minus 2. And they get me that. Definitely going to do another one. Then I ask them, instead of show me the first line of working, I'm going to ask them, what do I need to do to both sides? They get me that. Then they get me that. And then they get me that. Okay? So, in an ideal world. But if it's not, then I might need to put some other interventions in place. The important part is that I'm putting interventions in place. I'm not telling them the answers. I'm testing them. They're having to work it out for themselves, but with a lot of support from me. They're going to do another one. But what I might do is I might release it. Because they've actually got negative, they've understood the last one was -6, what I might do is release that and get them to show me the first line of working. So I'm working to maybe backtrack and put in some intervention and scaffolding, and then I might release some of that and say, okay, show me the first line of working when they're ready for it, and then away we go. That was one EE. That was one essential example. So hopefully you can appreciate that it's really about the pace and what we would do at that and the level of intervention that would be required in the lesson with those students. The next EE might look something like, essential example, might look something like this. And then we would work through it. I don't know, this next essential example might look a bit like this. You'll notice that the essential examples are pretty much the same thing. If one requires a positive answer or it's a whole number, so does the other one. You'll notice that I wouldn't have 3x equals 4 here. If this one was 2x equals 6 and that's going to give me 3, I wouldn't then go and make it this a fraction, for example, or put in a negative number. I make them definitely the same. Okay, so you will have worked out that we have 4 to 8 essential examples per PowerPoint, which means that some students that are further along the developmental pathway will reach the end much more of the length of the lesson much more quickly than some on the earlier. And so we've done quite a lot of thinking about this more recently. So we're still working our way through what this looks like. So this is very new. In fact, we provided quite a lot of internal PD to our staff last year on what this looks like. So when I was introducing the new learning, we want to keep the cognitive load really low. Okay? They've got a lot to think about. We want to keep it really low. So what do we want to do when we're doing extension? Well, we want to increase the cognitive load. But what we don't want to do is we don't want to give them next year's curriculum because that doesn't help them. We want to extend that where there's enough scope to extend them horizontally without having to extend them and teach them next year's learning. We don't do that. So what we do is we will increase the cognitive load by adding fractions. So imagine that same question with fractions, that same question with negative numbers, the same question with decimals. As soon as I do that, it actually looks like a different question because I'm increasing the cognitive load. And what we do in terms of extension is I would take a question from that lesson and I would actually increase the cognitive load on it. So that would be our extension. We don't source them from the internet or, because you can find some pretty challenging questions on the internet. And then what happens is that kids have to go and then research it for themselves, and that then creates misconceptions for them, and maths that they can't do, and then maths that maybe the teacher can't do, because some of those ones are, whoa. So, we don't do that. So we'll take a question from there and we'll just increase the cognitive load. So the other thing we might do is we might actually give them a question where we'll have extraneous information. So information that they don't actually need, okay? It's not worded problems. Worded problems are different. They're part of our core content. We will teach that as part of core. We give them diagrams with bits missing, and they've got to figure out the bit that's missing. So multiple step questions. Or usually if we're going to give them part A, B, C, D of a question to lead them through a question, we will just miss out part A, B and C and give them D. So what we're doing is we're taking exactly the same questions that we have in our PowerPoint, but we know how to add we know how to add cognitive load, and that's what we're doing for our extension questions. And some of the students will access those and some won't. But the students who don't are not disadvantaged. The students who do, they're just demonstrating the automaticity of their skills. And it's really important that we're making sure that it's not something that they haven't already been taught, because otherwise they're going to go and teach themselves and potentially develop some misconceptions. Okay, so where do we get to? Final line. So the students will have a different degree of automaticity. They will have a different degree of mastery of these skills. That's okay. But they will have all had the opportunity to be taught at their point of need within that one document or that one PowerPoint.